So, good evening, everyone. In this class, we are going to learn one of the method that solves a non-homogeneous linear ordinary differential equation, which is in this form. Equation number one, y double dash plus bxy dash plus qxy equal to rx. In this case, obviously, we assume rx is non-zero. Otherwise, if rx is zero, it becomes homogeneous. We are going to see that a general solution of equation number one is the sum of the general solution of the corresponding homogeneous ordinary differential equation, which is equation number two. In this case, we have taken Rx to be zero so that it becomes homogeneous. So solution of one will be nothing but summation of general solution of two plus a particular solution of one. Our main challenge is to find this particular solution. These two terms, general solution and particular solutions, are defined as follows. A general solution of a non-homogeneous ordinary differential equation 1 on an open interval I is of this form. Y equal to YH plus YP, where YH corresponds to the general solution of the homogeneous counterpart and YP corresponds to the particular solution of the non-homogeneous ordinary differential equation. So this following theorem ensures the existence of general solution of a non-homogeneous linear ordinary differential equation. Here we have written all the equations once again. Equation number one is the corresponding non-homogeneous equations. Equation number two is its corresponding homogeneous counterpart, and three, yx is yh plus yp. Here yh is c1y1 plus c2y2 is the general solution of 2, and yp is any solution of the non-homogeneous equation 1. The theorem states that if the coefficients px, qx and rx, the non-homogeneous part in 1, are continuous on some interval I, then every solution of 1 on I is obtained by assigning suitable values to the arbitrary constants C1 and C2 in a general solution 3 of 1 on I. Now, we are going to learn one method which will help you in finding this YP. The name of the method is method of variation of parameters. So in this regard, once again, we consider this non-homogeneous equation and its corresponding homogeneous counterpart. So the idea of this method is you find out the solution, general solution of the corresponding homogeneous counterpart. Let us call it C1y1 plus C2y2, where y1, y2 must form a basis of solution. What do we mean by basis of solutions? In this case, W of which we have learned earlier, y1, y2 must be non-zero. What is W of y1, y2? It is nothing but y1, y2, y1 dash, y2 dash. This determinant must be non-zero. Now let us discuss the method. So this C1, C2 are replaced by some functions of x, ux and vx. So let us assume yp is ux, y1x and vx, y2x. Our main challenge is to find out this ux and vx. Now, how to find out ux and vx? From this yp, it is assumed to be a solution of 1. So let us substitute yp and its derivatives y dash, yp dash and yp double dash in equation 1 and try to find out u and v. So what is yp? Yp once again is u y1 plus v y2. Find out yp dash. So that is your u dash y1 and so on. Now, in this one, we have to assume u dash y1 plus v dash y2 equal to 0. The moment we assume this one, then 4 becomes yp dash equal to u y1 dash plus v y2 dash. Now from this one, you do the derivative, double derivative. So yp double dash is this one. So what we have? We have yp, we have yp dash, and we have yp double dash. So that is all these three things you substitute in the given non-homogeneous equations. After substituting and arranging the terms a little bit, you get the expression like this. In this one, you see, since y1 is a solution of the homogeneous equation, so this has to be 0. Once again, y2 is also a solution of the corresponding homogeneous counterpart, so this also has to be 0. So what is remaining here is u dash y1 dash plus v dash y2 dash equal to r. Now we have equation number 5 and equation number 8 to find out our u dash and v dash. So from equation 5 and 8, we find out u dash and v dash. And see, in the denominator, w appears here. And since we have assumed y and y2 are basis of solutions, and that is why w is non-zero, since you can divide by w. So these are the expression for u dash and v dash. Now from these two, you integrate to find out u, and once you have this u and v, what is your yp? Yp equal to u y1 plus v y2. Substitute the values of u and v in this y. So you get yp equal to minus this one plus this one. So hence you find out you get the solution y equal to yh plus y. So this is the method of variation of parameters. Now let us understand this method using a example. So solve this one using method of variation of parameters. So what is your equation 1? The non-homogeneous equation, that is your y double dash plus y equal to sec x. In this case, see rx equal to sec x. Okay. Now what is the homogeneous? So this is your equation number 1. Then y double dash plus y equal to 0. That is your homogeneous counterpart. Now how to solve these two? You write the auxiliary equation. Equation is your m square plus 1 equal to 0. Solve this one. M equal to plus minus I. So what is YH? Sorry, YH equal to C1 cos x plus C2 sin x. So let us assume Y1 equal to cos x and Y2 equal to sin x. So the moment you have Y1, Y2, find out your W of Y1, Y2. So that is your Y1, Y2, Y1 dash, Y2 dash. If you find out this one, cos x, sin x, then minus sin x, cos x. So this is equal to cos square x plus sin square x equal to 1, which is non-zero. So hence we can use method of variation of parameters nicely. So now you can find out yp either using the whole method, or you can use the particular formula at the end. So yp equal to, so if you go back to the formula, what is it? See, minus y1 to y2r by w dx plus y2 into y1r by w. This way you can find out yp. Now let us find out. So this is equal to minus cos x into sin x. R is your sec x by w is 1 dx plus y2 is your sin x into cos x into sec x by 1 dx. So what do you get here? So now if you integrate this whole thing, so it will be, okay, let me write one more step, minus cos x integration sin x by cos x dx plus sin x integral x. So after integration, you'll get cos x to ln cos x plus x sin x. So this is your y. What is the general solution? So hence, general solution of 1 is given by y equal to yh plus yp. So this is equal to yh is c1 cos x plus c2 sin x plus yp, right? Cos x ln cos x plus x sin x. You can rearrange the term if you wish. Cos x into c1 plus ln cos x plus c2 plus x sin x. This is the general solution. So we have understood method of variation parameters and we have solved one problem. These are few more problems for your homework. Thank you. Have a nice evening.